So, if you are given a differential and asked to find the solution, but it says specific solution, that means we need to eliminate, oh no, we're not going to eliminate it, we are going to calculate the constant, okay? And we already did one of these today. So if we start with a slope field, and I'm going to show you why that's relevant. So if x is 0, what's the slope?
0.
1. Thank you for actually calculating that. Does y have any bearing on that?
No.
It does not. So we can just put 0 or 1 there. What if x is 1?
1/2.
Okay. Now do I have to be perfect
Yes.
with my slope of 1/2? No, it just has to be shallower than 1, right? What if I put a 2 in there?
1/3.
1/5? Again, shallower. Okay. What about -1?
0. It's not defined. Oh.
No, it's just half again.
Yeah, -1 squared is 1, so we got 1/2 again. And we're going to get 5th. Okay, so there's your slope field, right? Can you see the general curve? Right? You can see how it's going to look. Let's calculate the specific solution. Okay, separate the variables. Now what? Memorized integral. That's a memorized integral.
Oh, that's like
Is that what over x
That's-
and that?
Close.
Oh.
Tangent?
Closer. Negative tangent. Arctangent.
Yeah.
Tan inverse. Yeah. Yeah. Okay. Glad you guys thought that one up. Sometimes it takes a little bit, but I let you do it. So one of you did it. Okay. How do I eliminate the constant? That is the point 0, 0. Right? So the y is 0. The x is 0.
Is tan inverse a 0?
Do you remember how we think through these? Where, so that right there is asking
Where is tangent?
tan
0?
theta equals 0. Where does that occur? And remember, tangent is sine over cosine.
So like root 2 over 2, so n equals 45 degree angle. Root 2 over 2.
If sine over cosine is 0, which one of these has to be 0? Sine.
So it's pi.
Sine is 0 at
Pi. 0.
0, pi, 2 pi. Okay. If we look at our boundary, is pi in that?
No.
No, so it's 0.
Oh. Oh.
So what's our constant value?
0.
0. So y equals tan inverse x. Right? Okay, if we need to graph this specific solution, we are asked to. What's one point that we know?
0, 0.
Now, can you follow the lines from there? You're good. You're just following the slopes. Okay? Doesn't have to be even remotely close to perfect. Okay? Yeah. What boundary?
You said that it wasn't in the boundary. Oh.
Negative 3 to 3. Pi is not in that. Okay. What's the slope field look like? If y is 0, x is the 6, really steep. What if y is 1? Steeper. What if y is negative 1? So all these slope fields we're giving you so far have been just in terms of one variable. What if y is negative 2? 0. What if y is negative 3? Negative 3. All right. I think that's enough. Can I make that a separable differential? At this point, can I divide y over?
No, can't you multiply y over?
If I divide by y, what do I end up with?
Oh, y dy over here.
It's 3 plus 6 over y over here still, right?
Oh.
We have not been able to separate, so
Or to get rid of 3y.
okay, and I can't subtract or add, but there is something I can do to this to make it divisible. I'm going to factor a 3 out. Can I divide now? I can now divide the y out. The y plus 2, in fact. Okay, so I get 1 over y plus 2 equals 3 dx. And I didn't write my dy. If you see where we got that.
You like multiply the 3 and
Yeah, I factored the 3 out
then
and then divided by y plus 2.
it's like it went to the other side.
Yeah, you divide by it on both sides. An equation, you have to divide by both sides. Okay.
Wait. Why is it 1 over y plus 2?
Because you had to divide by y plus 2.
Or when you just, so dy dx is just a placeholder, we're not treating it as a variable right now? Because dy dx divided by y over 2, wouldn't that be the copied output?
It still ends up in the bottom.
Okay.
Yeah?
Yeah.
Okay. All right, integrate. What do we get? Left side? Wrong side. ln. Absolute value. Correct? Are you okay with that?
Yep.
Okay. At this point, you plug your initial condition in. And I can get rid of the absolute value now. Why can I get rid of absolute value?
Because there's a
What's the condition?
Positive.
Positive, oh. So
If that were negative, I would have to do negative natural log. All right, so we have ln of what? 1 plus 2
So 3.
equals 0, right? Plus c. So the natural log of 3 is the constant. And then we have to rewrite and solve for y. So we have natural log y plus 2 equals 3x plus ln 3. Right, so now how do we solve this for y? Yeah, e. So y plus 2 equals e to the 3x plus natural log 3. And then subtract 2, right? I'm going to tell you right now, a multiple choice answer will not match what you just had. If you subtract 2 right now. Okay, we have to use properties of exponents to simplify this. E to the 3x, e to the ln 3. Remember that rule?
Yeah.
Okay, what is this? Yeah, it's 3.
Oh, 3, yeah.
Right. Okay, y plus 2 equals 3 e to the 3x. And then subtract your 2. Right? That's the only real place you have to be careful is with this. For some reason, those calculus people think that that's a lot nicer and prettier. Functional.
Is minus 2 in the exponent or is it?
No. Okay. Then map that specific solution. What was our point?
0, 1.
0, 1. Go through that. And then just follow the slopes. That looks like an e exponential, right? E to the 3x. Okay. We don't have time for the third one. Heard that. Okay, any questions there? Guess we don't have time for number 17, Jason. I mean Mason. I will make this assignment smaller. Whoa.
Yeah, that's just,
Is this what we already did?
yeah, that's the spider web we
Oh.
already did.
So just.
I will make this assignment smaller. And then we used an AP strategy there too by crossing our work out instead of erasing it. Save time. There you go. 1, 2, 3, 4, 5 problems. We'll grade it tomorrow.